Guys, I want to show you from the start how to get this thing set up. This is like the cheapest battery charger on the market or whatever. And we're going to use this for our electrolysis rust removal and our zinc metal electroplating of our brake caliper and its slide pins. Okay, so you first plug it in and removal and electroplating, you want a maximum of 2 amps. So we'll do 2 amps. This is a Lipro balance charger. It's a piece of crap. But it works. I mean, piece of crap in terms of price. I guess it's pretty good though, right? And we want 14 volts. Because my notes say 10 to 14 volts and 2 amps will get good results. Okay? And click enter. And we're there. I believe we're good. I don't know if it needs to detect a battery before it will start those. I think some chargers do that. So it might do that. And it might not detect anything when we just try to get a reading. So I don't know if it's just going to be outputting blindly. No, it's not outputting anything. We might need to connect a lead acid battery to it to get it, like, running. I guess. Which would be fine. It would keep the lead acid battery... Wait, no, that wouldn't do 2 amps then. Oh, come on. I don't know if this is going to work, boys. Sorry. This is not good. Okay, so... I mean, unless if I'm missing something... I click start, it all appears right, but I don't think it's actually going to do anything. So, I believe that this will not work. We are going to have to use, I guess, a laptop charger like this. And, Frankenstein it with like a light bulb as a resistor, as a variable resistor. The same way we restored the dead lead acid battery project. If you guys recall, we used a light bulb in series in order to get the voltage down to an acceptable level. And I did all the math on that. We can look up my notes on that and hopefully get this sorted out and be able to successfully get a controlled 2 amp 14 volt current to flow for our electrolysis rust removal and electroplating needs. If we connect the 19 volt charger to a buck converter, we could drop it down to 14 volts. Alright. And then, from there, no, let's do 12 volts. Let's drop it down to 12 volts with a buck converter from 19 volts to 12 volts. And then let's do 2 amps. 12 times 2, that's 24 watts. We do not want to connect a battery to our electrolysis setup because I'm concerned that it would burn out the battery by over discharging the battery. I don't know how much resistance is in an electrolysis setup. So that could cause the battery to very quickly overheat as it sends current through that vinegar water solution too quickly, and it could just short out the battery. So we don't want that. We want to create a current limited solution using resistors and a 19-volt battery power supply, so that it can run all night and not have the battery run out. So a 19-volt laptop battery power supply is what we're starting out with. We want to drop it down to 12 volts first with a buck converter. Once it's down to 12 volts, we want to limit the current down to 1 to 2 amps. So I equals V over R is Ohm's law. 12 volts divided by R, so I we want to be 1 to 2. Alright, so 12 volts, if it were 12, that would make it 1. 12 times 1 is 12 watts. My resistors are rated to about 10 watts. So they can handle 12 watts, I bet. That should be fine. They'll get hot, they'll be fine. So that's what we'll do. We'll drop it down to 12 volts. We'll use 2 resistors. So it's going to look like this. Here's what our circuit will look like. Let me first show you the math. So I equals V over R is Ohm's law. And we're going to do a 19-volt laptop battery power supply through a buck converter, drop it down to 12 volts. And we want to take that 12 voltage and limit the amps with resistors. So we're going to do 12 volts divided by, we'll use 2 resistors that are rated to 10 watts. They're each 5 ohm resistors. So 2 of them in series will make 10 ohms. So divided by 10 ohms is going to equal, I equals 1.2 amps. And 1.2 amps, so watts equals current times voltage. So watts equals 1.2 times 12. Watts equals 14.4 watts. Our resistors are only rated to 10 watts, but we're going to put a PC cooling fan on them and a heat sink so that they won't like burn up too much and keep them cool. Okay, so I think they'll be okay. And the actual circuit will look like this. Here is the battery charger coming from the wall. Here's the plug. And we're going to cut it in half and splice it. We'll take the positive and the negative, and we'll run the positive side through a resistor and then another resistor. Both of them are 5 ohm resistors that are rated to 10 watts. And then we now have a current of 1.2 amps and 12 volts. Well, no, we had to first connect it right here, okay, to our buck converter, and then from the buck converter, it's now 12 volts, dropping it down from 19 down to 12. Okay, and now with our 12 volts running through 2 resistors, it'll be 1.2 amps only gets through. And then we connect this to our sacrificial metal and our car part. And I don't know which one's which. Let's verify that next. So it's going to be well, shoot, we can figure it out. The positive runs the current toward the negative terminal. And so we want to put the positive pin on the car part because the current will flow through the car part and away from the car part and into the sacrificial metal. So we'll put the sacrificial metal on the negative. That's simple. So the positive will be car part, So here is our laptop charger. We'll name it charger. 19 volts. Buck converter. Those cost like $3 from China. That buck converter will drop the 19 volts down to 12 volts. And it's going to run 1.2 amps through our system. It's going to go through the car part on the positive side. We'll name this positive, negative, and then it's going to go into a sacrificial metal. And that's our circuit. And here we have a 5 ohm 10 watt resistor, and here we have another 5 ohm 10 watt resistor. And a resistor is indicated by a squiggly line. We have two of them in series, so their resistances add. So 5 plus 5 is 10 total ohms of resistance. And we wanted 10 ohms of resistance so that I equals V over R, that's Ohm's law. The 12 volts coming from our buck converter divided by 10 gives you 1.2 amps, and that's ideal. That's a nice amperage to run through our car part and into our sacrificial metal. So current is going to go through here and into there. The current flows from the positive toward the negative. The electrons flow from the negative to the positive. So as the negative flows from negative to the positive, the current flows the opposite way, from positive to negative. So the current will flow through the car part and into the sacrificial metal. And the current will carry with it rust, and the rust will cling to the sacrificial metal, leaving the car part. Now, these will both be inside a bucket. There's our bucket. And there's our solution. And you do not want the copper wire or any copper stuff to touch the solution. It will eat away at the copper. So you'll clip it to the sacrificial metal just above the water surface. And you'll clip it to the car part just above the water surface. Or you could wrap a wire around the car part and then clip it to the wire so that it's not actually touching copper into that water. And that's the whole plan. This solution, this liquid solution, is going to be made of white vinegar as our acid, Epsom salt or sea salt. Do not use table salt because that will leave toxic fumes. We want 1 tablespoon per water bottle of vinegar. So we're going to fill it up with vinegar, and each water bottle we add approximately 1 tablespoon of Epsom salt we're going to use. And then we'll go from there. Alright. We got our battery charger. We know it works. And we want to reopen it. We've done it with this thing before. And we will splice off of it. This time we're going to splice it permanently and leave it out while leaving this part intact, so that this thing will become a multi-purpose tool, always available to provide us with a power supply, in addition to the standard barrel plug, which leads to plugging in our battery charger over there. Okay. So if we open it up, we can see what's going on here. Okay. Let's get some scissors. I'll let you guys zoom in on what I'm doing here. I sure hope my electrolysis happens faster than that guy. He took 72 hours, 3 days, and it was still barely doing anything. Okay, so that's our ground, because it's the outside wrapping wire that's exposed, and now we're doing the positive. And our whole goal here is just to just splice off and leave some little alligator clips, small ones, I think. Or we could just splice off with wire. Nah, we'll do alligator clips. Okay. Um, Trying to picture what wire size would be acceptable in terms of the gauge. I think jumper wire should be fine, because it runs servos. Jumper wire, this is servo wire, and servos pull 800 milliamps, 700 milliamps, so that's about an amp. And we're going to be pulling only 14 watts, which, since we're going from 19 volts through a buck converter, it's going to be like 0.7 amps running through the buck converter. So that's about the same as a servo. So we're good for sure. I just verified it mathematically. Alright, so let's go ahead and get out a red and a black jumper wire deal. And let's cut them here. And we'll strip them. Okay. 1 and 2. Let me strip this one a little more. Okay. Now we will solder it. Alright. come on. I needed some flux. Oh, come on. I am just struggling here. This is ridiculous. I hate when things don't go easy. Alright, I'm gonna go ahead and pretend this. Now, solder it on. Okay. Now for this other side, I'll solder this guy on. And let's get the clipboard out. Why is this moving? Okay. Okay. We now have a solid electrical connection. You can see there, I spliced off red off the white line and off the black line of black. And now I just have to insulate them. So boom and you. Okay. And now I gotta insulate the ground side. Okay. And now I want to use my special Q-tip trick. Q-tip and electrical tape to provide stiffness to the joint area so that it won't bend back and forth there and eventually snap from being used. This trick has helped me and been tested very well. These brittle joints where you solder, it weakens the copper wire when you solder, and it makes it brittle because of the heat shock. The rapid heating and cooling makes it brittle and less flexible because it's no longer tempered, which is a blacksmithing term. And that means that the brittle spot is more likely to break there. It's a weak area of the copper wire. So you don't want it bending where your joints are. You'd rather have it bend where the nice tempered, soft, flowing wire goes. That doesn't break. Your brittle spot will break. So this Q-tip provides stiffness to the area so that it doesn't bend back and forth there. The Q-tip stick is a stiffener. It's like a splint. And because electrical tape peels off at the ends, we use really good homemade tape made of nitrile gloves and adhesive transfer tape to tape that off. And there we go. So now we've got our two wires freed coming off of here, but we've still got our barrel plug available right here. So we could tap into it either way. We can still plug this into our battery charger, but then we've got these nice little insulated alligator clips coming off, and it's like the best of both worlds. It's a win-win for everyone. You know, the water's going to provide some resistance too, so I don't think the resistors are in too much danger. I think the amperage will be even lower than we expect. Okay. Let's get out this buck converter. This is rated to 20 volts in, 17 volts out, and anything below. So we're going to do 19 volts in, 12 volts out. And it also can handle, by the way, 1.8 amps output. These are super cheap. They're like $1.50 from China. Here's what they look like. Just pretty much search on eBay for buck converters and sort by lowest price, and you'll see them listed for like $1.50 or $3 or something really cheap. Okay, so we got our buck converter. And oh. The back is labeled in and out. Okay, got it. So in is on the right, and we're going to want to solder wire into that first. Then we'll clip our alligator clips to that wire. Alright, we got a box of pre-clipped stuff here, so we'll just grab a green and a red. These are just little jumper wires, pre-stripped. Oh, hey Drunken Sweep. What happened to your username then? We might actually need more of these. Let me just set them there for now. Stick the red in positive like that. And the green and negative like that. We'll need our helping hand. Okay. Now I'll get my soldering iron ready. I'm going to pre-flux it. And get out my solder. I'm going to clean this thumbnail. It's annoying me. It's dirty. Working on cars, my nails get dirty. I don't like that. Okay. Whoops. Yeah, I'm doing well. How are you? Doing electronics, man. I'm living it up. To get to combine car work with electronics is pretty fun. It's like any chance I can get opportunity to combine passions, use my vast knowledge in different fields to benefit other fields, why not, right? Oh gosh. Holy crap. We knocked a resistor off its whatever it's called. I need magnification. It's a tiny resistor. The smallest of the small. Put too much solder on our wire and then I got clippers. Go ahead and clips. Thanks for letting me know I'm muted. Good grief. Okay, let me say it again. Alright. So here's our finished soldered joints. If it wants to focus, which I don't know if it will. Okay. It's a MH Mini 360 buck converter. The two pins on the left say out minus and out plus. The two on the right say in minus and in plus. I managed to splice out of our laptop 19-volt charger cord while still retaining the barrel jack on one side. We now have two wires coming out with alligator clips on the ends. and this is all nicely resealed. And these will just remain permanently out for when we want to tap into it, not with the barrel, for projects. Now, the 2 alligator clips clip onto the 2 input pins going into our buck converter, so that's easy to remove and re-add. And the buck converter can drop it down anywhere from 17 volts all the way down to 2.2 volts, whatever we want. And this little screw on the buck converter, right there, if it'll show it, there on the bottom left, you can see it real clear. When you turn that screw, you can change the output of the buck converter to whatever voltage output you want. So we're putting 19 volts input. It can handle up to 27 volts input. And we're going to output it down to, what did we say, 12 volts, just like a battery. So we need to actually plug it in and run a test and use our multimeter to make sure the voltages are as we expect. I believe I'm done with all soldering. No, I'm not. Actually, we're going to need to put the series resistors in as well. On the positive side, we'll add some resistors next too. So I'm not done soldering. Well, buck converters have built-in resistance, right? Will they output enough to short themselves? Probably will. Okay, I wanted to do, well, we wanted 10 ohms of resistance. 12 divided by 10 was going to be 1.2 amps. But that 10 ohms of resistance has to be able to handle around 14 watts. These are only rated for 5 watts. Alright, boys. We got it now. We got it now. We have 18 gauge Nichrome wire. So let's look at this. 18 gauge Nichrome wire has 0.42 ohms per foot of resistance. Alright, that's great. So how much resistance did we want? Ideally, with our resistor solution, which doesn't work out because we have resistors only rated for 5 watts, and we want to run 14 watts, so we need a much bigger resistor. Well, 18 gauge Nichrome resistance wire is 0.42 ohms per foot. We want to get 10 ohms. Heck, if we can afford it, I wouldn't mind running 2 amps, so we could go 6 ohms. 12 divided by 6 is 2 amps of flow. We're using 12 volts. So, we'd want 6 ohms ideally. So 6 divided by 0.42 ohms per foot. Okay, 6 divided by 0.42 is 14. Wait. If it were 1 ohm per foot and we wanted 6 ohms, then that we'd want 6 feet. 1 ohm per foot, we want 6 ohms, okay. So it would be 6 divided by 1. If it's 0.5 ohms per foot, it would be 6 divided by 0.5, which is 12 feet. Okay, so it is divided by, okay, so we want 6 ohms, 6 divided by 0.42. Yeah, it's 14 feet of nichrome resistance wire is what we want in order to get 6 ohms of resistance. We need 14 feet of wire. That's a lot of feet, but that's okay. That wire is not going to get that hot, but it'll be hot enough to kind of burn the grass. If anybody walked over barefoot, it'd get burned. 14 feet. Alright, 14 feet. You heard it here, folks. And you know what? This stuff can handle a stupid high amount of amps. Because it's nichrome resistance wire. Unlike a resistor, which can like blow up and burn out, this wire doesn't blow up and burn out. It just turns red hot. It can be used in a furnace. It doesn't melt. It has a super high melting point. So we can run all the whatever we want, and we won't be burning out anything. So all we have to do is clamp to it, and we're good. Ha! All right. We're ready, guys. We're ready. We need 14 feet of wire. Alright, I'm ready to move this to the outdoors. I just have to put on a big hat to guard my neck and head from the sun, and I gotta put on pants because I'm very badly sunburned from last time. I don't think, well, maybe he needs it. YOLO! Let's fill it up with vinegar. 1 water bottle, 2 water bottles, 3 water bottles, 4 water bottles, 5 water bottles, 6 water bottles. That's about 6 water bottles worth. So we need 6 heaping tablespoons of Epsom salt or sea salt. We're using Epsom salt, which is magnesium sulfate, which is for like bats when you're sore. So that's about a tablespoon, 2 tablespoons, 3 tablespoons, 4 tablespoons, 5 tablespoons, 6 tablespoons. So we got our 6 water bottles worth of white vinegar, 6 tablespoons of Epsom salt, and I guess we could stir it. Maybe. I don't know if you should. Alright. You're supposed to clean it with wax and grease remover first, but I didn't do that. YOLO, I'm not going to bother. I think that's more for electroplating important. I don't think it's so important when you're going to soak this for days in acid, for crying out loud, you know? That's my guess, but I could be wrong. I think it's fine. Don't let the 2 pieces of metal touch. I didn't know that. I didn't think about it at all. Alright, let me get a clamp out of here to make sure that the sacrificial metal stays the heck away. Well, no, actually that wouldn't cause a short circuit because I have enough resistance already in my circuit with the nichrome wire that it will never go over the amount of amperage I have allowed already, if that makes sense. That's why I use the nichrome wire, in order to limit the amperage flow that's possible. So even shorting them out wouldn't actually matter in this application because I thought ahead or whatever.
Alright, so we got wire hitting that, flowing. Okay, we got current coming off of this, 12 volts coming off this little buck converter. Can you see my hand? Alright, so we got our laptop battery charger, 19 volts, which then runs and comes out to these two red and black splice wire alligator clips. We spliced it in, and then that's 19 volts going into the buck converter. The buck converter drops that down to 12 volts. So from this point on, it's the same as if we had a battery. We could have used a lead acid battery or any 12 volt battery, which would have been totally fine. We just wanted it not to be a battery because this can run for infinite, day after day after day. Okay, so now we got 12 volts, infinite. We got an alligator clip connected to some copper wire right here off the red wire. The copper wire then connects to Nichrome wire. Nichrome wire has 15 feet, creating, it's 18 gauge Nichrome wire, creating the amount of resistance we needed, which was 6 ohms of resistance. And then we got, and it's 0.42 ohms per foot, so we did 15 feet. And then we got it wrapped to another piece of copper wire, because we know that this Nichrome is going to get real hot. It's resistance wire. So it'll get hot, but we got the separation so it doesn't melt anything with the bowl or whatever. And then it goes directly to the steel wire, which is connected to the car part. And then the car part will flow current across to the sacrificial metal, where it will build up here on this sacrificial metal plate connected to our ground line, running back to our battery or power supply, which in this case is a little buck converter. So that's the full circuit. And I believe it's safe to plug it in now. I'm just going to clean up a couple things for the grand moment we've all been waiting for, where I plug it in. I don't think anything magical is going to happen, but I think this is one of those things where checking on its progress is the exciting part, I guess. I don't know. Everything's completely submerged. The two metals are not touching. The rush should be able to flow across the electrolytic solution. Everything looks good. The white vinegar is already kind of eating away at the rest. You can see bubbles coming off it. It's already doing chemical reaction. It'll be cool to see a ton of bubbles once I plug it in, which I'll do now. Heck with it. Let's go. Wait. Actually, I'm worried about one of the electrical connections. I'm going to redo one of these connections because I didn't scratch away the copper on one of them, and I don't like that. I want to have the copper scratched away to make sure there's good contact. I don't want that to be a point of high resistance all of a sudden. And again, I just ran the Nichrome up to the light post against the house, and it's a brick wall and a metal light, so that heat will just hit the wall and not harm anything. And it'll hit the light post, which is like a big heat sink. You could wrap it around anything. A door handle, if you're Kevin from Home Alone. You want the door handle to be hot? Okay. This is how a good joint should look. Just wrapped up real good, real tight. And you want to use a tool too to really crank it down, so that it has good contact, and it won't be a source of resistance based on not contacting well. Because you don't want more resistance. We already calculated all the resistance we need. We don't need more. Alright, I'm plugging this bad boy in. You can see a good amount of bubbles already, by the way. Alright, so it goes from our power supply all the way through the cord to where it splices out. It hits our little buck converter. We follow the red line. It comes all the way through into copper. At the other end of the alligator clip is a copper connection. Well cleaned. I made it nice and shiny. And then the copper comes all the way up, well cleaned, connects to the Nichrome right here. And then our Nichrome, here's the Nichrome resistance wire. Here's a connection. It's 15 feet of that wire. Then it connects to another one. And then it goes down the copper to cool it off. We don't want Nichrome connecting directly near the bowl. And then it goes to the wire that connects to the car part. So that steel wire connects to the car part. We have no copper inside the wire because that would create I don't know, some kind of reaction you don't want. I think some kind of toxic gas or something, I don't know. Or it contaminate the water. So you can see it's already bubbling, and I don't even have it plugged in yet. And then from the ground, it's just going to this sacrificial metal right here, and it's going to travel through there toward the metal, and then it goes to the ground of the power supply. That little buck converter is our power supply. Alright, I'm plugging it in, boys. 5, 4, 3, 2, 1. It's plugged in. I'll get you guys a close-up. See if it starts bubbling like crazy. Whoa. Look at that go. Look at that. I guess I'll set up a camera on it. I don't know. Like without holding it, I'll set up my tripod to do this all day as well. I got it backwards. I got it backwards, boys. I got it backwards. No wonder. It looked like it was flowing off of our sacrificial part. So we cleaned the rust off the wrong part. Alright, positive. Everything's just reversed. Positive goes on the sacrificial metal. Negative goes on the car part. So now we should see a reversal of the flow. The car part should start bubbling furiously. It is! Actually, I want to look at the part. I won't get electrocuted if I only touch the part. Okay, nothing happened. Now, aren't you glad I'm thorough? I would have had The cleanest sacrificial metal part ever. And the dirtiest car part ever. Yep, you're right, TXT. So now this isn't bubbling at all, but this one's starting to bubble a lot more. Alright guys, I just connected the red to both of them. The alligator clip. So now we got double the surface to cling to. Because there's a lot of rust that's going to be going onto these. How to rust your car parts DIY. That'd be a good video title. I feel like what will make my electrolysis video stand out is using a laptop power supply rather than a battery charger. You don't have to buy anything fancy. Most people have that around, except no, the fact that you can use any 12-volt power supply. So you can use a 12-volt battery. Anybody has that. And then from there, all you need is 15 feet of 18-gauge Nichrome wire. Oh, nobody has that either. Okay, never mind. People are going to have to buy stuff no matter what. So I didn't really save anybody anything, but maybe they learned something about Ohm's law. I don't know. I don't know what I brought to the table, but it's just a different way to do it, so that's something, right? Alright, so positive is on the sacrificial metal because current flows from positive to negative and electrons flow from negative to positive. So electrons are leaving the car part and traveling to the positive sacrificial metal, and the electrons are actual physical particles that carry chunks of rust and stuff. So that's what's happening. I just pulled it out. Here's a little container here. I have to say, I ended up setting this up. Let me show you what I did. This is 2 days later. I made a couple adjustments yesterday, which I did off camera. Okay. Here's what I did. I'll show you. This was like this. Okay, like that. But I had it completely underwater. Like this, okay. And then we had I removed the resistor. Alright, so electrons go from the negative toward the positive. So the positive goes on the car part. And this is live, by the way. The negative goes on here. There's not a whole lot of bubbling action going on. And then I also connected this car part over here. I mean, this sacrificial over to this sacrificial metal. So that we would have two sacrificial metals because it was removing metal, or it was removing rust in line of sight with the sacrificial metal. So the part, this side of the car part here, whatever was closest to that metal was getting removed more, and whatever was on the back side, the rust was still pretty heavy. So I wanted it to remove rust from both directions. So that's why I put one on this side and one on this side, and they're connected to ground together. No, I got it backwards again. Son of a buck. Sorry, guys. No. It's supposed to be like this. Boom. And then boom. So electrons go from the black ground, and those electrons travel toward the positive, carrying rust with them. That's how it goes. And this is connected to the car part. So the negative goes toward the car part. And this wire should be red because it's positive, but I just happen to use a black wire. But you can see that the red wire is going onto the sacrificial metal, and this black wire, which should be red, is connected to the other sacrificial metal, and that's what's happening. Now, you'll notice that it's not bubbling much because I think the reactions are kind of getting done. I don't know. Now, you could say, well, maybe it's not transmitting electricity anymore, right? So I tested that, and I'll show you the test with my multimeter. It's still alive. Or it was. Let's test again. Okay. Got one probe there. And I think you guys can see the multimeter reading. It's bouncing around a lot, but it is on. Also, if I take it off the car part, so it's not like doing weird stuff, you'll see it's a solid 11.41 volts. So that has not changed. It just bounces around a lot because it discharges quickly when it's connected to this solution. It has very low resistance now because we took the resistor off. All right, the amperage thing on this thing is not working anymore. I think I blew the fuse at some point. I don't know how that happened, but suffice to say, it is still running the current, and the amperage was doing 3.5 amps for like a second, and then it dropped down to 0 amps, and then 3.5 amps, and then 0 amps. And that was when the output capacitor of our buck converter, which is this little thing here, this little circuit board here, was getting discharged. It would become 3.5 amps, then it'd go down to 0 because it was discharged, and the buck converter would go back into a charging mode where it charges itself back up, and then once it's charged up, it releases that charge through the inductor and allows 3.5 amps again. So that's what was happening. A pulsing 3.5 amps was what was happening. Okay, so Let's go ahead and take the part out and do some analysis here. Wait, first we've got to disconnect our power. It's been 2 days, so I'm thinking we're done. I'm not wanting to let it go anymore, and the bubbles kind of stopped, so it seems like it's no longer working, or things are too rusty. It's not transmitting as well now, something like that. Let's check out these sacrificial metal pieces. They don't look that dirty. Maybe since we used vinegar instead of washing soda, since we used vinegar and salt, maybe whatever rust got onto here got kind of eaten off of here by the vinegar, so it didn't get that rusty like it would have with washing soda. You know what I mean? So these didn't get that rusty. They're actually pretty clean. They're cleaner than when I started. Well, whatever was above the vinegar got more rusty. And then the part itself. See, white vinegar by itself is actually capable of removing rust without electrolysis. So the electrolysis is just icing on the cake. Okay, so I think you can see there's actually totally clear metal right here. You can see. And it's really clean around here. You can see. It's looking really good in a lot of ways. We'll just kind of scrape a little bit and see what happens. It's still kind of rusty. I mean, it's much better, but I'm not going to sit here and scrape this thing. Hey.
I snuck up on you. Oh, you're talking to someone.
I am. I'm streaming right now. I'm live. I'm on the air. So, let me get some water. We'll spray it off. It's definitely a lot better. You can see there's a lot thinner rust in these corners. I mean, most of it is gone, but not all the way. It's also totally clean in this edge. It's a million times better, but also what I really notice is inside the teeth, where the bolts go, it's actually really clean in the teeth. So that's nice. Because I think that rust wasn't that thick, but this was very thick rust. So I'm not happy with this. I want to make a parts tumbler to finish it off. So we're going to do that next for the final finishing. Everybody that does electrolysis rust removal has to do a lot of elbow grease afterward. And they always do that off camera, and then they just show the before and after. I'm not going to do that. I don't want to do the elbow grease part. I want to do it the lazy man's way. Use technology all the way, rather than some technology and then end up still having to go with the wire wheel and still, you know what I'm saying? Like, it'll make the wire wheeling easier because this loosened it, but I don't want to do the wire wheel at all. I want to have it all done through technology. So the next step, we have to make a part tumbler. Now, I've seen a lot of videos on part tumblers. Wait, before we go into that, let me just say that I was willing to risk burning out my little buck converter here because I saw other people connecting 12-volt batteries directly, and I guess this has a decent amount of resistance in this rust and water and steel, and it just didn't burn out their batteries. And other people used wall wart power adapters with 12-volt outputs, and it didn't burn out those adapters and short circuit them because I guess there's enough resistance in here that it doesn't burn things out as much in this bucket of rusty metal and stuff. So I guess you don't need a resistor, but I still think it's smart to use a resistor like I did if you really don't want to break anything. It's safer and lowers any type of fire hazard risk. It becomes totally safe if you input the proper resistance like I did. It's optional, in other words. I have to go eat. I'll be back to finish up here with the part tumbler. That's going to be a separate video anyways. But the final finishing will be a part tumbler. So, conclusion, electrolysis rust removal works in white vinegar with 1 water bottle of white vinegar to 1 scoop of magnesium sulfate salt, Epsom salt, and it got most of the rust off. You can install this back in your car, but I want to take it much further. I want to get this down to absolute bare metal in a part tumbler next, which is just a rattling bin full of an abrasive material which just scratches away at the part until it's down to bare metal. And you can actually do that without the electrolysis, but the electrolysis is great for getting inside the little nooks and crannies and clearing out the threads and getting everything loose, and then the part tumbler will finish the job, getting rid of all the scale left behind. But most of this rust has been converted to a black stuff and has been loosened and a lot of it removed, and now it's just a matter of wire wheeling it away or using some abrasive to get all the rust off. And we're going to create a part tumbler. Now, to create the part tumbler, you can buy tumbling medium and buy a part tumbler if you want. I want to make my own on the cheap and on the real easy. I want to make a super simple one. And it's going to involve a hand sander for the vibrations, strapped to the side of a bucket real tight, and then the tumbling media in the bucket, and the bucket will just rattle. That's the principle. You want the bucket rattling hard. And that will cause the tumbling medium inside it to scratch away and cut away at the rust and clean it to a nice polish. For the tumbling medium, the best overall medium, they said, was ceramic shards, which they sell for like $13 for 5 pounds of ceramic tumbling medium. But I'm going to make my own ceramic tumbling medium using my grandma's old pottery, or my grandma's old ceramic dishware, or china, it's called, ceramic china. I'm going to break it all with a hammer and use that as tumbling medium. She bought it from thrift stores and stuff, and she collected it. And I was going to try to sell it, but I don't think it's worth much, so I'd rather use it as tumbling medium. So I'm going to go break all that and put it in a container, and strap a hand sander to it real tight, and it's going to rattle around and it's going to clean it amazing. I saw another video on YouTube where they used cat litter, which is very coarse. It's got little rocks in it, and that worked nice as a tumbling medium. But yeah, I don't want to have to buy tumbling medium. I'm pretty sure you could even use like a ton of nuts and bolts as tumbling medium, and those would rub against whatever you put in it and clean themselves and clean it. The point is something hard that will rub away, and the finer it is, the more fine details it can carve out. If it's real coarse, if I like put this with a bunch of tent stakes or something, it probably wouldn't get in every little detail. So you want something kind of fine if you want to have a fine polish. You can use a lot of things as tumbling medium. You can use bearing balls. You can use nuts and bolts. You can use cat litter. You can use ceramic. You can use little pieces of hard plastic. You can use crushed up walnut shells. You can use little pieces of like granite or different types of stone that are hard that they sell as tumbling medium. They each give finishes. Oh, corn husks ground up into little grains of corn husks from corn cobs or whatever. They grind that all up, but not too fine, and that can work. I believe even sand can work, but corn husks and walnuts are ideal for soft metals where you don't want it to bite into the metal too much. But since this is cast iron, we can use something a lot harder like ceramic. But ceramic, they said, is good for almost all materials. So ceramic is actually not too bad. But if you use something really hard like diamonds or something, it would, like, over time, eat this whole part into powder. I'm theorizing. So you don't want something too hard. You don't want something harder than the part you're trying to grind away at. Ceramic will turn to powder if you try to crush it. So that's why it's safe, because it's not going to, like, destroy this. It will just remove anything loose on it, if that makes sense. It'll remove the rust, it'll remove layers without damaging the original metal. You don't want it to damage the original metal. So that's the plan. Alright guys, so here's it with it dried off. It does look a little different. You can see it's got like a yellow little thin glaze of rust, and a lot of the rust just pretty much scratches off with your fingernail. It's just like scale. So this would come off with a cleaner and a scrub brush and some elbow grease. It's like just rubbing off. So it is decoupled from the metal to some extent. But I want to put in a part tumbler, as we said. I just wanted to show you the follow-up. And then these brake slides, you can see the rust is just, look at that, just coming right off. Really good. This was all an electrolysis bowl, so it's just all coming off. This will be great to reuse now. Same with this one. Boom. It's just all coming right off. So yeah, the process works. Electrolysis works, man. I'm gonna save my bucket for the other brake caliper bracket from the other wheel, because I'm doing both of the rear brakes. So I'm gonna save this for later. I'm just keeping it in the corner of the garage here, right there by the garage door. This is the little garage door laser. Here's the garage door opener track. Just keeping it in the corner where nobody will kick it, and that's where I had the electrolysis happening. It's right near the garage door, so whatever hydrogen bubbles up, that will, flow out of the door or whatever, which is not perfectly airtight. So I feel that's a great place to do it.